So today we're going to be working on area of regular polygons. Now there's two ways to kind of look at it when you're trying to solve for that area. There's the plug and chug method and the think and link method. I'm going to focus on the think and link method because I think it'll be more conceptually understanding and it'll help you guide yourself through it more than the plug and chug. The plug and chug method you'll find in a lot of textbooks where it just says the area is 1/2 AP, which means you need to know what the A is and what the P is. The A stands for apothem and P stands for perimeter. You'll know what perimeter is, but the apothem is kind of a new vocab word that is attached to regular polygons. To me, I think it's a lot easier to understand the math if you think of 1/2 base times height. That you know, oh, he's talking about triangles. I know how to find the area of a triangle. I've done that plenty of times. I've hardly ever done the area of a regular polygon. So if we go back to our basis, back to what we know, we're going to find the area of a triangle. And when you find that area of a triangle, there are multitudes of that triangle in the polygon. So we're going to count how many triangles you have and add them up. So let's look at a couple regular polygons and discover those triangles. So you would have a regular pentagon, regular hexagon, regular octagon. It can be as many sides as you want. And the key to being regular is all the sides have to be the same and all of the angles have to be the same. That's what makes it a regular pentagon or regular hexagon or any other sided polygon. So we're going to take a look at one of those and explore it. So let's do on the next slide, we're going to look at the hexagon and explore what I mean by finding the area of a triangle instead. So for a hexagon, we'll have one here. Okay, notice that this is a 6-sided figure, and so since it's 6-sided, let's look at 6 equal blue triangles. So let's look at those 6 equal blue triangles. I'm going to make sure they're blue. The key to getting these is go from corner to corner and it goes right through the middle. Okay, so I have 6 blue triangles. So if I can find the area of one blue triangle, I should be able to multiply by 6 to get that whole area of the hexagon. Now, two key ingredients to area of a triangle is knowing the base and knowing the height. Okay, so a lot of times in the problems that will be given to you, they will always tell you a side length of the polygon. So they might tell you that this is 10, and that's referring to that side. And since it's regular, you also know this side's 10, and this side's 10, and this side's 10, and this side is 10, which is most importantly that my base is 10 for that blue triangle. Okay, now I need to get the height of that triangle. Now this is where I have this stick figure bird that's going to help us work on that. So I'm going to try and blow up right now. I'm going to blow up this part of the blue triangle. This guy here, I want to blow up a bit and explore that over here. Okay, so that pink part of it, or purple part of it, we're going to look at over there. Okay, first thing we know is if this whole side length was 10, over here on the bottom, this piece would be 5 because that's 10 and half of it gets me the 5. Okay, now with that, I really care about right now this angle up there. I need that angle. And we can get that by looking at this bird as it spins around the hexagon. Okay, so I'm going to practice the spin like that. If a bird spins a whole loop around, okay, watch with the beak. If the bird spins a whole loop around, that one revolution is 360 degrees. Okay. Now my question is, look at the beak as it goes from the green to the blue, from the green to the blue. I want to know what that angle is. Okay. Now the key to this is this. 360 degrees will get divided up equally through the blue parts. Look at this. It goes 1 blue, 2 blues, 3 blues, 4 blues, 5 blues, and all the way back to 6 blues. Okay? Well, if there's 6 blues, look at how many green sections there would be swooping through. Okay? Now watch as I swoop between a blue and a green, and I got to make sure I can get this bird back. So give me a second. Now watch this. One swoop, there's 1. There's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 swoops. It takes 12 swoops to go between a blue-green or a green-blue. And so what you can do is 360 degrees divided by 12 equals 30 degrees. That means every little swoop right here, there are 12 of them, and each one is worth 30 degrees, which gives me a 30 degrees right there. That is key because the whole thing that we still need right now is the height of the triangle right there. We need this height. Now comes some trig. If you have this 30 degrees, you can see that this side here is the opposite side, and this side here is the adjacent side compared to that 30 degrees. And when you have the opposite and adjacent, you can do tangent. So you can do tangent of 30 degrees equals opposite over the adjacent, which happens to be the height that we want. Okay, so tangent of 30 equals 5 over h, and we're going to want to solve that. So I'm going to pull up my calculator here, turn it on, and I hope to turn it on. There we go. Always make sure your mode is in degrees. And we're going to go back and we're going to type in tangent of 30, and we get 0.577. So I'm going to put that here. 0.577 equals 5 over h. So from here, you would cross multiply and go 0.577h equals 5. Divide by 0.577 on both sides, and h equals, so I'm going to get 5 divided by 0.577, 8.67. Now this is the height of the triangle. So from there, what you have is you have kind of a couple choices here. You could say you are looking at a purple triangle that has a 5 here and an 8.67 here. And you could say there's that, and there are actually 12 of these. Or you can look at it as this being 10 with this being 8.67, and there's 6 of these. Regardless, it's easy to find the area of a triangle and then multiply by how many of them that you have. So if you wanted to do the purple way, you could say base times height divided by 2, and that equals 5 times 8.67 divided by 2, 21.65, 675, and there are 12 of those. So if you multiply that by 12, you get 260.1. Or you could do 10 times 8.67 divided by 2. 10 times 8.67 divided by 2 is 43.35. 43.35 times by 6 gets you again 260.1. And this number here that I keep talking through, 260.1, I don't want you to lose sight of it. This is the area, either one of these is the area of the entire hexagon that we started with, right up there. Okay, so I talked a lot about it, of drawing triangles. So a way I like to kind of set things up for my sake when I solve is I don't care how many sides the polygon is. I like to try and set up drawing the right triangle, which in this case would be my purple triangle. I'm going to solve for the angle, solve for the height, find the area of a triangle, and then find the total area. So if I have one like this, what I could do is, again, I could draw in my blue triangles. Notice it's a pentagon. There are 5 sides to a pentagon, so there's 5 blue triangles. And then from that, I can take a blue triangle and cut it into my purple triangle right here. So from that, if you have an 8 all the way across on every side, 8, 8, 8, 8, 8, 8, 8, you will notice that the bottom part there is 4 because it's half of it. Now, there are 5 blue triangles, which means there are 10 purple triangles. And when you talk about that guy with the eyeballs looking, that guy would spin through 5 blue triangles, but he would be spinning through 10 purple triangles. So if you need the angle, you can go 360 divided by 10, which in this case gets you 36 degrees. That 36 degrees is right there. Now I'm trying to find the height of the triangle. And when you do that, you have the opposite side, you have the adjacent side. So again, you'd be using tangent. Tangent of 36 equals opposite over adjacent. You can go to your calculator and check on tangent of 36, 0.727 is 4 over h. I like to think of that as over 1. Cross multiply, divide by 0.727. You get h equals 5.5. Now, think about this purple triangle, and I'll just draw it again for you here. You have 5.5 and a 4. So area of the triangle would be base times height divided by 2. Okay, that gets you 11. That is the area of this purple triangle right there. And to get the area of the pentagon, you just need to realize that there's 10 of those purples. So I can do 10 times that 11, which gets me 110, and that's the area of the total pentagon. So that's it, a little bit more organized and laid out. Hopefully these help, these 2 examples on finding the area of a regular polygon.